Hi, I'm Dr. Papya Bhattacharjee. In this problem, we have to find the maximum volume of a box. And as you can see in this picture, the box is resting on the xy plane and one of its vertex is at the origin and the opposite vertex is given to be on this plane, 5x plus 2y plus z equals to 10. And you have to find the maximum volume of such a box. Okay, so it's a maximizing problem and the function that we have to maximize is the volume. Okay, so let's maximize volume. Now how do we compute volume? You know, it's the length times width times height. So let's say the volume is x, y, z, where x is the length of the box, y is the width, and z is the height. And it also makes sense from the picture of the box itself, right? Now we want the function, this volume function, to be in two variables. So, but there are three variables, so how do we change it into two? Look, there is a relationship between x, y, and z. So from here we can solve for z. So let's say z is equal to, take the 5x and the 2y to the right hand side. So you get 10 minus 5x minus 2y, and then rewrite our volume function. Okay. So let's say the volume is then x, y times z is right here, 10 minus 5x minus 2y. Let's simplify. So we get 10xy minus 5x square y minus 2xy square. Okay, so we have a function in two variables and we know how to find maximum for this function. We have to take the derivatives and set it equal to 0 and then find critical numbers. Okay, so let's compute Vx, which is the partial derivative of the function with respect to x, which means y is constant. All right, so let's look at each term. So the first term, 10y is constant, derivative of x is 1. Then we have negative 5y is constant, and the derivative of x squared is 2x. Finally, negative 2y squared is constant, and derivative of x is 1. So this is Vx, and let's see, Vy will be same thing except x is constant now. So from first term is 10x times 1, second term negative 5x squared, and the derivative of y is again 1. Last term negative 2x times y squared derivative is 2y. And you know what to do, right? We have to find critical numbers, so to set them equal to 0. Okay, so let's simplify these expressions one more time. So let's see, what is Vx? Notice that every term we have a common factor of 2y. So you can pull out 2y and we will be left with, from the first term we have a 5. Second term we have negative 5x and then negative y. Okay, and then for Vy, let's see, what's the common factor? We have x and we have, no, just x. Okay, so from the first term we have 10, negative 5x, negative 4y. All right. Now, we need to set this equal to 0 and then solve, right? Okay, so from the first expression, look, there are two factors. And so the product equal to 0 means each one will be equal to 0. So we will have either y is 0 or this entire expression is 0. Now think about it. If y is 0, whatever critical number we get for that, When you come back to your volume function, y is 0 means volume is 0. So there is no box, right? How can that give us a maximum volume? It will not. Look at this other expression, same way. Either it will be x is 0 or this entire thing is 0. Now if x is 0, same thing happens, right? The volume is 0. So we won't be getting the maximum volume using those critical numbers where either y is 0 or x is 0. So we can ignore those completely. And we only consider when these two factors are equal to 0 and then solve for x and y for them. Okay, so let's consider 5 minus 5x minus y is 0. 10 minus 5x minus 4y is 0. All right, now we have to solve for x and y. See, there are two equations in two variables. And I can see that these two equations, they have this negative 5x sitting, right? So why don't we just subtract one from another? So I'm subtracting the bottom one from the top. So the 10 is negative, this negative is positive, negative 4y becomes positive 4y, and see the 5x cancels out, negative and positive. And then we'll be left with 5 minus 10, so we have a negative 5. And then plus 4y minus y, so plus 3y is equal to 0. And you can solve for y right away, right? So 3y is equal to 5, so y is 5 over 3. And from here, let's solve for x. So you can take the first equation, say. So let's see. So we have 5 minus 5x minus y, but y is 5/3, that is 0. So we have negative 5x, 5 minus 5/3, so that is 5 minus 5/3, 3 minus 1, 2 times 5 is 10, so plus 10/3, that is 0. And so we have 5x is equal to 10/3, so x is equal to 10 divided by 5 is 2, is 2/3. Okay, so we get our critical number. And that is 2/3, 5/3. Now note that we already explained that this will be the maximum volume, right? This will give us, because all the other critical numbers we have ignored because they will not give us the maximum. So we don't have to check any further, but this will give us the maximum volume. We have to figure out what that volume is and look at the volume formula. We have x times y times z. So we have to first find what z is when given x and y. Okay? And you know z is right here in terms of x and y. So z is 10 minus 5x minus 2y. So write down x is 2/3, y is 5/3. Okay, so this is 10 minus 10/3 minus 10/3. So that'll be, this is 2/3. So this is 10/3. Okay, now finally our maximum volume is 2/3 times 5/3 times 10/3. So that is 100 over 27, and this is cubic units. So this box has the maximum volume of 100 over 27. Thank you.